dear students. This is the fourth class on the chapter Calculus Recapitulation, and in this class we will be discussing about the average value of a function and approximation. That is the approximation, and that is the to find out the value of the function using approximation method. And now, first of all, we are going to discuss about the average value of a function. And so you know that in case of arithmetic, very often you need to calculate the average value or the mean value of a given series of numbers. So if you have a given series of numbers as a1, a2, a3 in this way up to an, then the average arithmetic average or the mean of these numbers is calculated by using the relation that is a average is equal to first sum of all the numbers, that is a1 plus a2 plus a3 in this way up to an, and then by dividing this sum by the total number of the numbers, that is n. Since you have n numbers you have in this series, so the average is equal to given by a1 plus a2 plus in this way an by n, and that can also be written as 1 by n, sum I is equal to 1 to n ai. Now in calculus, if you have given a function fx which is defined in the interval a b, and if you need to find out the average value of this function, you have to employ this method, that the method that will be discussed here. So first you think that the function that you have given is divided into n number of intervals having equal difference, okay, between the two successive points. So you have given a function fx, and that is defined in the interval ab, and you see and you consider that the interval ab is divided into n number of elements or n number of intervals, and thus, and in each of the interval, the fx is defined, that is, it has certain values, definite values, and between two successive points, the value of the function is continuous, successive, okay. And let then the interval delta x can be written as, since the interval is b and b, so b minus a by n. Here the number of intervals is n. So delta x, that is the difference between two successive interval. It is delta x. So delta x is equal to b minus a by n. So in that case, the function, since you have divided the interval that is ab into n number of intervals, having say the values of x in that intervals are x1 x2 in this way xn, and the difference between these x1 and these x2, these 2 points in delta x. So the average value of the interval delta x, since you have divided this interval b ab into n number of intervals, so delta x can be written as b minus a by an, subject to the condition that each interval has equal value. So from this knowledge, you can write the average value of that function, that is equal to, first of all you have to sum of all the values of the given function for different values of x. So for first value x1 it is fx1, for the second value x2, that is, it is fx2, in this way it is fxn. So this is basically essentially the sum of all the values of the functions in that interval, which is divided into n number of intervals, n number of sections, okay. So this is the sum of the function, and then it's need to divide this sum by the total number of intervals, that is n. So f average is equal to 1 by n, fx1 plus fx2 plus in this way fxn, and that can be written as 1 by n sum I to n fi xi. In the limit if you consider the limit, that is this interval is very high, that is tends to infinity, then the average value can be written as f average, that is your limit n tends to infinity, then 1 by n I is equal to 1 to n fi xi. From this relation, it is not very difficult to understand. And also you have delta x is equal to b minus a by n. So that is also written here. From here you can write this 1 by n. 1 by n, that is equal to delta x by b minus a. So from the relation, that is this relation, f average now can be written as limit n tends to infinity. Then this 1 by n is written as delta x by b minus a. So b minus a is written here. This is completely a constant quantity. So 1 by b minus a. Then sum over I is equal to 1 to infinity. Then this fi xi and this delta x is there. Okay. And if you write this sum in the form of integration, that you can then you can easily write from this expression that f average is equal to 1 by b minus a, then integration this, because since the interval is ab, so it should be, the limit should be a to b fx dx. So if you have, so from this relation you can easily calculate the average value of a given function, but in this case you have to be provided the interval of the function where it is defined. Okay, so if a and ab is the interval, then f average is equal to 1 by b minus a to b fx dx. Also, if y is a function of x, then the average rate of change of y with respect to x in the interval ab is given by. So here is another important relation, that is we have given two functions. Number one is your y, which is a function of x, and then the the average change of y with respect to x is given by, in the interval obviously ab is given by f average is equal to the value of the function y when x is equal to b, that is here, minus the value of the function y at x is equal to a, that is here, divided by the interval, the value of the interval, that is b minus a. So this is the average value, average change of rate of change of y with respect to x. This is the condition. And from here this is relation, and from here if you substitute this b minus a by h such that p is equal to a plus h, and in that case you can write f average is equal to a plus h minus fa by h. Okay, so now come to instantaneous value. So this is here, the instantaneous change of y with respect to x. So in this case, so you remember that is it has mistake has been taken, that is in this case limit b tends to a here, and here the limit should be h tends to 0. This is missing here, but you have to consider, you have to note of this, that if ever is a limit h tends to 0 here. So now instantaneous value, the instantaneous value of y with respect to x at the point x to a is given by, this is another important relation, instantaneous value you wish to find out, that is b tends to a fb minus fa by b minus a, that is equal to limit h tends to 0. Then you know in this case b minus a is replaced by h. So from here b is equal to a plus a. Just substitute this. So limit h tends to 0. Then f of a plus h minus fa by h. So this is the required relation, that is important relation through which we can find out the instantaneous value of y with respect to x. So this is there. Now uh, now you can have another one, that is the instantaneous value of the velocity, or the instantaneous velocity of a particle is given by. So this is v written as, that is equal to h tends to 0, following this relation, f of h plus t, then minus f of t by h. Obviously you should remember that in this case f of t is equal to s, that is the position of the particle at time t. So if you know the position of the particle at the time t, that is at t, and at an interval h plus t, that is h tends to 0, then you can easily find out the instantaneous velocity v from this relation, limit h tends to 0, f of h plus t minus ft by h. Okay, in the similar way, you can use another alternative method, that is the instantaneous change of displacement with respect to t, that is ds by dt. So p can be written as ds by dt. Okay, this is another, this is an alternative way. And now the acceleration, the instantaneous acceleration can be calculated by using the differentiation of the velocity with respect to t. So dv by dt, and that can also be written in the form of limit as, that is h tends to 0, g plus t plus h minus gt by h, where gt is the velocity uh, function of the particle at the time t. So you can calculate, and now we are going through some examples. First one is the average value of fx, that is equal to x cube at the interval, on the interval 1 3. So here the given function is 2x cube, fx is equal to 2x cube, and the average value, you know, the average value of fx in the interval a3 is given by 1 by 3 minus 1 1 2 3 integration 2x cube dx, because this is the relation, this is the formula, that is f average is equal to 1 by b minus a, here b is 3 and a is 1, integration a to b, so 1 to 3 fx means 2x cube then dx. Just calculate, the calculation is not very difficult. So finally you obtain the average value of the given function is 20. Now another one is here, another example is here, the average value of the function fx is equal to sin x in the interval 0 to pi. So the given function is fx is equal to sin x, and the average value is, you know, from the relation that is here, that is written also here, that that will provide you 1 by pi minus 0, that is b is here pi and a is 0, so 0 to pi, then fx dx, that is equal to 1 by pi 0 to pi sin x dx, and the sign of integration of sin of dx is equal to minus cos x. And now use the limit, you finally obtained 2 by pi. So the average value of sin x is equal to 2 by pi. And another one example is there, the velocity of a particle is given by vt is equal to 3t square plus 2. Find the average velocity over the time interval 1 less than equal to t less than 3. So in this case the interval is actually 1 3. So in this case, so vt is given as 3t square plus 2. So the average value is 1 by higher value, that is 3 minus 1 1 to 3 bt dt, that is equal to half. This will give, will provide you a half 1 to 3 t square plus 2 dt. Just integrate. This is not very easy, it is very easy to find out. So finally v average is equal to 15. And now another example is there, y is equal to y square minus 4, y square y square plus 4, then find out the instantaneous rate of change of y with respect to x when x is equal to 3. So we will find out the value of the instantaneous change of rate of change of y with respect to x in two methods. Number one is using the method of limits, and number two the method of the calculus, that is in this case if y is your displacement, then t with respect to, that means dy by dx, using the formula dy by dx. So first of all we are here going to find out the instantaneous value of y with respect to x using a limit, using the knowledge of limit. So from here the function is given y is equal to x square plus 4. Then the instantaneous value of change of y with respect to x is given by the formula limit b tends to 3, because the point is here 3, f b minus f a by b minus a. This definition is given in our he given here. This definition is here, limit b tends to a, f b minus f a by b minus a. So that is here. Here b is actually here a is actually 3, that is given here, f b minus f a by b minus a. So here a is 3, then fa, that means in this expression you have to use the value of a is equal to 3. So a is equal to 3 at the point, and in this case a is equal to 3. So then fa is equal to 3 square plus 4, that is 13. So this fa is equal to now 13. So limit b tends to 3, and you know from this relation that y is equal to x square plus 4, that means fb will be b square plus 4, that is here b square plus 4 minus f3 function of 3, that is equal to limit b tends to 3, then b square plus 4 minus 13 by b minus 3, and this has the form b square minus 9 by b minus 3. Just simplifying, we finally obtain limit b tends to 3 b plus 3. This is the simplification process, and that will give you, using the limit of b, 3 plus 3, that is 6. So the instantaneous value is 6. Here we here another another method, that is alternative method, is there. Using the derivative method, the instantaneous value of y with respect to x is given by dy by dx. You know it at the point x equal to 0. So y is given here x square plus 4, so dy by dx is equal to 2x. And now substitute the value of 3 substitute the value of x as 3 in this relation. So dy by dx is equal to the 6. So these two relations are equal. So this can be compared in this way also. So this is the instantaneous value of y with respect to x is 6. Another example is here. A particle is moving on an x-axis whose position vector is given by x is equal to 2 plus 4 minus t square. Find the instantaneous velocity at time t is equal to 3 seconds. So here is the two method can be employed in this case. And the first method is the knowledge of limit. You know the definition of definition is here, through which we can calculate the instantaneous velocity of fx, and I am leaving it for you using the knowledge of limit. All the steps are also here. Just go through this and calculate yourself and check with your calculation with this one that is done here. But I just go interested to go to the derivative method. But you have to practice it. You must practice it, okay? And then also compare with the alternative method, that is the derivative method. Here you have given the function as x is equal to 2 plus 4 t plus t square. So dx by dt, that is equal to v, that has the value 4 minus 2t. From here 4 minus 2t, and use the value of t is equal to 3 in this expression dx by dt, that is equal to minus 2. And in this case also I have calculated minus 2. So the instantaneous velocity is minus 2 meter per second. You have to check it. Now come to another important topic, that is approximation. And this approximation method is very useful, or it is a very powerful tool to approximate value of a function. And the beauty of this approximation method will be reflected in our in some examples that are calculated, that are shown here. So first we need to have the knowledge of approximation. So if you have given a function y is equal to fx, and this function is differentiable, and if x is incremented by an amount delta x from x, then the increment of the function fx is given by delta fx. Okay, you know, because in this case the initial value was x, and then x is incremented by an amount delta x. So now the value of x is x plus delta x. So the function should definitely increase in this case, incremented in this case. So the incremented value of this function, that can be written as delta fx, and that can be found out from the value of this fx, this function, at the value x plus delta x minus the initial value, that is fx, that is written here. So delta fx is equal to f of x plus delta x minus fx. Okay, now just we wish to differentiate this. So differentiation of this function, that is fx function, not this differentiation of the function fx, that is f prime x, and you know the definition of f prime x from the knowledge of limit, that limit delta x tends to 0, this delta x should be tends to 0, then the value of this, that is the function fx at x plus delta x, that is f x plus delta x minus the initial one by this increment delta x. So f prime x can now be written as limit delta x tends to 0, fx plus delta x minus fx by delta x, and this can be written from the knowledge of limit. So that is equal to limit delta x tends to 0, and we know we already seen that here. We have already seen in this expression that this f function of x plus delta x minus fx is equal to delta fx. So from this relation you finally obtain limit delta x tends to 0 delta fx by delta x. Okay, now from here, so left hand side is this and right hand side is this, and from here you can write from this relation you can write delta x, this delta fx, sorry, this delta fx. From this relation you can write this delta fx, that is here, is equal to this fx f prime x into this delta x. So from this relation you can write delta fx is equal to f prime x into delta x. Okay, now from the equation number 1, this is equation number 1. So delta fx is equal to fx plus delta x minus fx. Here also delta fx is equal to a prime x into delta x. So this right hand side and this right hand side will equal to each other. So that means that means uh, that means if x plus delta x, okay, this minus this fx is equal to a prime x delta x, or from here there if x plus delta x is equal to this term plus this fx, so fx plus delta fx. So this is from equation number 2. So this equation gives us, so finally we obtain the value of x plus delta x is equal to fx plus a prime x delta x, and this is the average value of the function fx, and this is the mathematical definition. And from this equation we can calculate or compute the average value of the function fx. And obviously you should have the condition, you have to follow the condition that fx should be differentiable for a given point, and derivative and its derivative should be continuous and different and continuous neighboring the points that we will be given. So the condition is that the approximation of a function can be obtained if the function is differentiable and its derivatives at neighboring points are known. You have to know. Now examples are here from which uh, you can understand the application of from the average value of a function and its beauty to compute the average value. So first one is that find the approximation value of root over 101 using differential calculus. So you write one thing that y is equal to fx, and since it is the square root of a function of a term, so of a number, so write it as root over x. So y is equal to function of x, that is equal to root x. So just write this as that x is equal to 100 and delta x should be 1. So just write is here x is equal to 100, and because you know you can write it as 100 plus 1. So here x is equal to 100 and delta x is equal to 1. Now just differentiate this function, that is a prime x, that will provide you 1 by 2 root over x, okay, square root x. So then from the definition of the approximation value of function, that if x plus delta x, you know that if x plus delta x is equal to fx plus a prime x delta x, that we have obtained here, this relation that is written here, if x plus delta x, fx plus a prime delta x. So x plus delta x, here x is 100 and delta is 1, so that is f101 100, that is equal to f function of 100, that is x is there 100 plus a prime x means 100, and delta x you have calculated, you have written as delta x is 1, so that is 1. So if 100 means you know that x is equal, if x is root x, square root x, so x is 100, so square root 100 plus 1 by 2, then square root 100, and this one is there, this one is there, so that is equal to 10 plus 1 by 2 into 10, 10 plus 0.05, that is 10.05. So the approximation value of square root 101 101 is 10.05. So this is very interesting. Now find out the value of 122 to the power 3 by 2 by approximation method using differential calculus. Let y is equal to fx, that is equal to x to the power 1/3, because in this case see here the function here the power is 1/3. So if you use the value as x, so x to the power should be x to the power 1/3. And since it is 122 and 122 can be written as 125 then minus 3, So here x can be taken as 125 and delta x can be taken as minus 3. That is that x is equal to 125 and delta is equal to minus 3. And let y is equal to fx, that is equal to x to the power 3, and then from here f prime x is equal to this 1/3 here, and the derivative of x to the 1/3 is equal to x to the minus 2/3, that is equal to 1 by, it should be 3, okay, it should be 3, mistakenly it is written as 2, so 1 by 3 x to the power 2/3. So now, and the approximation value of x, now we know, given by fx plus delta x, that is equal to fx plus f prime x delta x. So that is equal to, here fx, your fx is equal to x to the 1/3, then plus f prime x is equal to 1 by 2 x to the 1 by 3, sorry, 1 by 3 x to the 2/3, then delta x. So x is 125 and the plus is there, delta x means minus 3. That's it, 125, x is 125 to the 1/3 plus 1/3 here, then 1 by 125 to the 2/3 into minus 3, delta x is minus 3 here. So just use the value, you can write this and this term as 1/3 this, then 125 is equal to 5 to the uh, 5 to the power 2, then you can write this cube and then 2 4 is there, this, so finally this is 5 cube, okay, and into, this is into sign, okay, into sign 2 by uh, here 2 by 3, sorry, it should be 3, oh 3 is also, it is 3, it is looking like 4 but not, it is 3, and this 3 and this 3 has been cancelled. So actually 5 minus 1 by, this will 5 and 1 by 25, that is equal to this 5 minus 0.04, that is equal to 4 minus, that is 4.96. So 122 to the power 130 is 4.96. That is, that can, it is calculated fantastically. Another example is here. Find the value of 1.001 to the power 3 plus 2 into 1.003 to the 4 by 3, 1.001 to the power 4 by 3, and then plus 5. So here also, since it is written, it is see from the relation that if you take x as 1, then delta x should be 0.001. That is also written here, and the function fx should be from the first term x cube and from the second term 2x to the power 4 by 3, and it is 5. So f prime x is equal to, just differentiate it and you will have 3x squared plus 8 by 3x to the power 1/3. So the, now from the definition, the approximated value of y is fx plus delta x, that is fx plus f prime x delta x. Now just use the, write the value. So from fx equal to x cube, then plus 2 into 4, x to the 3 by 4 plus 5, and then here is the value of prime x and then delta x. Now just substitute the value of x, that is equal to 1, and delta x is equal to 0.001, that is done here, and this is the calculations, and after being calculated the value becomes 8.0057. So the value of one, the given number, that is this, is equal to this. So now come to another one example. This is the last example of this class, that is given that log e base 4 is equal to 1.3863. Find the value of log 4.02. Okay, so here just you consider that x is equal to 4 and delta is equal to 0.02. That is also written here. See here, x to 4 and delta is equal to 0.02, and then the function should be y is equal to fx is equal to log, since it is log x. So f prime x is equal to differentiate of log x means 1 by x. So then the average value would be, approximated value will be, the value of fx using approximation method is f x plus delta x, that is fx plus f prime x into delta x. So log ex plus 1 by x delta x, just use the value of this, and now substitute the values of log e base x, x means here 4 plus 1 by x means 4 into 0.02. So after being calculated, the value of log 4.02 is being calculated as 1.3913. So this is the value. So in this class we interestingly learn the approximation value as well as the average value, which will be very helpful to calculation in our different subjects or different disciplines like physics or chemistry also. So students, you need to go through all these calculations.